Hello everyone. We are starting our free open lecture on our Discord. If you are a viewer and want to ask questions and get answers in an online format, join our lectures. You can find the link to our Discord in our Telegram channel. And now, we are moving on to the list of tasks for practicing this topic. The first task is not very difficult, meaning the tasks here generally go from simple to complex. In the second task, which is directly on an array, we will look at different implementations and solutions for this task. We will see how it works if solved by brute force, how to solve it using binary search, and how it can be written in just one pass. So, the complexities in this case are decreasing. And now let's move on to the first task. It's called the triangle made of sticks. The time to solve it is 1 second, the memory is 32 megabytes, and its difficulty is only 7%. This means it is one of the simplest tasks you can find on this topic. And now the conditions. Timofey has 3 sticks with natural lengths A, B, and C from which a triangle can be formed. In one operation, the boy breaks off a piece of length 1 from each stick. What is the minimum number of operations after which a triangle can no longer be formed from the sticks? For clarity, assume that from sticks of unit length you can break off a piece of length 1 after which the stick will disappear. And now we are told that we have input data. These are 3 lines of the input file input.txt. Meaning we are simply given 3 values on different lines, and there are 3 numbers, ABC from 1 to 10 circumflex 9. The triangle inequality is guaranteed for the given lengths. That is, the triangle inequality, the properties of the triangle inequality, if you consider it, this given triangle inequality guarantees us that for any sides, if you take them, in this case it is written for A, that is, if A is less than the sum of B and C, or B is less than A and C, well, more precisely, and at the same time B is less than A and C, and at the same time C is less than A plus B, then in this case, such a triangle will exist. This is about what the triangle inequality is and its properties existence. In the output file, output.txt, you will see one natural number, the answer to the problem. That is, in this problem, we are told, if we look at the example in more detail, that we are given these numbers and the answer here is 4, and here is an example. We have one side of 10, another of 12, and the third of 18, and each second. One stick is broken off from each side. So, it was 10 and became 9, it was 12 and became 11, it was 18 and became 17, and then it was 9 and became 8, it was 1 and became 10, it was 17 and became 16, and so on. And at some point in time it turned out that we have one side of 6, another of 8, and the third of 14. This means that the triangle inequality does not hold, so we have 14, which already becomes equal to 6 plus 8, and not less.
Want to become a great programmer? Subscribe to our Telegram channel.
Accordingly, in this case, the triangle rule by its existence has indeed already failed. Therefore, the answer is 4. That is, after 4 seconds, the answer stopped, meaning this decrease stopped and the answer became 4. In other words, 4 operations. This problem can be solved mathematically. Today I won't show how to do it, as it can also be solved with a single formula, but we are specifically interested in the solution using binary search. So what is happening? I understand, yes. If we look at this problem in more detail, problem number 1, if we examine it more closely, we see that we have 3 numbers A, B, and C, and we understand the rules of existence for B and C. That is, specifically for the triangle, these are the rules. A is less than B plus C, and B is less than A plus C. In particular, specifically, as we can see. And here we have C less than B plus A, or A plus B. So these are the requirements and conditions for the continued existence of this triangle. This is a system, meaning that each condition must be met at all times. What happens here is that we want to deduct from each value at a certain point in time. For example, when the value is 4, in 4 seconds, we subtract 4 from A and 4 from B and add them together. This can be written like this. And we also add C minus 4. In this particular case, when substituting our values for A, B, and C, it turns out that the sign is not less than, but rather it becomes equal. As a result, 6. Here it turned out to be 8, just like in the parentheses, right? It turns out that the sign does not become less than, but rather it becomes equal. That is, therefore, the triangle rule no longer applies. The solution here can be seen using binary search. We are actually interested in what is the minimum or maximum number of sticks we will definitely take away. In the extreme case, if we have some values, for example, 8, 12, and 14, the triangle rule will definitely not exist. Essentially, this triangle will not exist if one of these values is set to 0. For example, if the 8 is the smallest, as we subtract equally from all values by 1 unit, the first value will become 0 after such subtractions. So we definitely take away 8 from each, 8, 8, and 8. Roughly speaking, after 8 operations, we will have 0, 4, and 6. Thus the triangle definitely does not exist anymore because of this. Because 0 we will need to compare, for example, 0 plus 4. 4, yes. It is obviously greater than 6, meaning it is not greater, so here it is already violated. Therefore, we will apply binary search. We look at which of the elements among these three numbers is the smallest. In this case, it is the 8. And in fact, this will be our right boundary. So our right boundary will be the 8, and our left boundary will be 0. Accordingly, we subtract 1 from each element. Roughly speaking, if we draw a number line, our left element will be 0, and it extends further. In this case, the condition states that the numbers are natural, and they all lie naturally. The right boundary is 8, so our index ranges from 0, 1, 2, 3, 4, 5, 6, 7, meaning it lies within these boundaries. Initially, there is an inequality when the original values are given. Therefore, for example, with the 8, it can exist. In this case, it seems like we have a triangle here. The values indicate that the triangle exists. We need to subtract from 0 to 7, and in the same way, we will set the left boundary here, the right boundary there, and calculate the centers each time. And thus, in this particular scenario, recalculate. But we will no longer compare with some target element, as was written in our theoretical part, because we do not have a specific element that we want to find, specifically, as mentioned earlier, and we want to find such an element where the inequality does not hold. Therefore, we will compare to ensure that all given conditions are met. To simplify this, we will sort our array, that is, in ascending order, because our first element could be, for example, 14, the second one 12, the third one 8, or 8 could be in the center, with 14 on the left and 12 on the right, or 12 on the left and 14 on the right, and 8 in the center. So, there can be several different variations. To simplify this, the search for the minimum element, I just immediately sort this array of 3 values. I get what we need, that we have the minimum element and the other 2, and then I will just compare them carefully. What interests me the most is that the sum of the first 2 numbers should be greater than the sum of the maximum number among them. Because if we have 14, which is greater than 12, for example, then 14 is greater than 12, which follows from basic mathematics. It is easy to understand that 14 and the sum of any natural number, for example 8, will obviously be greater than the second number, and if 14 is already greater than 8, then obviously if I add 12 to it, it will also be greater. So, in fact, our main concern is when the 2 smaller numbers become either equal to or less than our largest number. Now let us write this down.
Want to become a great programmer? Subscribe to our Telegram channel.